Assalamu alaikum everyone, my name is MD Ahsamul Haque. Today we are introducing a presentation which is based on the Intruder alarm using 555 timer. So basically in our presentation there are 5 members including me. Those are Farzana Binte Kafil, Mohammad Yeasin Ali, Mochaddec Hossain and Tasnuva Tasnim Mim. The table of content of our presentation is introduction, component, intruder alarm, simulation and the discussion. So introduction part will be discussing with provided me. What is the 555 timer? The 555 timer is an IC that is used in different applications like an oscillator, pulse generator and timer. The name of divider from the 35K resistor in the IC. The name of function of the IC is generated and isolated timing pulse. There are the 8 part or pin in 555 timer. Those are. Now I am discussing about the pin configuration of 555 timer IC. As you can see, the ground is the first one. All voltage are measured this respect of this terminal, and the second one is trigger. When a voltage below T1/3 VCC is applied to this pin, the output of the timer becomes high. The output remains high as long as trigger terminal is held low voltage. And the third part is output terminal. The output of the timer is measured here with the respect A to ground. The fourth part is reset. The 555 timer can be disabled reset by applying a negative pulse to this pin. And the fifth part of this pin configuration is control. When the voltage is this pin greater than equal a threshold voltage T2/3 VCC, the output of the timer is low. The sixth pin name is threshold. By imposing and the voltage of this pin by the connecting a port between this pin and the ground, the pulse width of the output waveform can be varied. The seventh pin name is discharge. The pin is connected initially to the collector of the transistor Q. It acts an open circuit when it's turned off. Again, it acts as a short circuit when it's turned on. VCC. The last part of this 555 timer configuration of IC. The supply voltage of 5 volt to 18 volt can apply this pin respect to ground. So
Assalamu alaikum, I'm Farzana Binte Kafil. Now I'm presenting a 555 timer basic charging phase which is on stable mode. In this timer we can see 2 comparator, one SR latch, a buffer and a BJT transistor. Initially when the power just turn on, the capacitor remains uncharged and thus the trigger and threshold also remains at 0 volt. The B comparator will give us an output of 1 and Q1 is off. C1 begins to charge through the R1 and R2 when C1 charge just below 1/3 VCC. The comparator V will give us output 1 and A will give us output of 0, and the flip-flop is going to set and the transistor is still off. Again, when the C1 is charging and it is above 1/3 VCC or beyond 1/3 VCC, the comparator V is 0 and A also 0, but the main output will be still 1, that's mean unchanged, and Q1 will be still off. Q1 is our BJT transistor which will be still off, and thus we can see during the charging phase the output of 555 timer remains high. Now let's talk about the discharging phase. Once the voltage of the capacitor is beyond 2/3 VCC, the comparator A becomes 1. This resets the flip-flop and the output becomes 0. However, the Q1 turns on and the capacitor begins discharging. If we get the voltage of the capacitor below 2/3 VCC, the comparator A becomes 0 and the main output remains unchanged and capacitor is still in discharging mode. So we can see that in discharging phase, in the 555 timer we get the output 0. So if we now get the voltage of the capacitor below 1/3 VCC, the comparator V becomes 1 and A becomes 0. So the main output will be 1 and the flip-flop will again going to be set. And this is how the charging phase again going to start as a cycle. It will continue.
Assalamu alaikum sir, I am Mochaddec Hossain and I'll now continue the presentation. Let's get introduced with the alarm system. The idea of our project is to catch any intruder breaking into an unauthorized area. And to achieve that, the alarm will go off as soon as the intruder triggers the alarm. Here is a basic working diagram of our alarm system. Initially, the switch is connected and the reset is turned on, so the alarm is off. But when an intruder triggers the alarm, the reset will be open from the ground. Thus, the timer starts its operation and starts to send signal pulse to the speaker. As in astable mode, we know that the output of the 555 timer will send pulses. So, pulses are sent to the speaker and the speaker receives the signal and starts making sounds. Next, we'll see the hardware implementation. Here you can see all the components and they are connected as required to achieve the astable mode of the 555 timer. Now we'll see the video of our circuit. This is the hardware implementation of the 555 timer intruder alarm, and it uses a 9-volt battery for power supply. The VCC of the 555 timer is connected to the positive rail and the pin 1 ground is connected to the negative rail. The reset pin of the 555 timer is connected to the negative rail. And when an intruder is detected by the motion sensor, the reset pin will connect to the positive rail. The alarm consisting of the buzzer and the LED will keep going off until authorities resets the alarm.
Hello everyone, myself Mohammad Yeasin Ali. I will be explaining the simulation and the circuit part of the project. So at first, if we look at the circuit, we have a DC generator which is connected to the timer to provide necessary power. Then we have an interactive switch that controls the reset pin of the timer. Then we have a speaker that is connected to the output pin of the timer. This is the reset pin of the 555 timer IC. The reset pin is the most crucial pin for this project, as we can manipulate the timer with this pin via a switch. So if we move to the circuit simulation, what actually happens, we can see that when the switch is connected to the IC and it is connected, the reset pin is enabled, and once the reset pin gets disabled, once we disconnect the switch, what actually happens is when an intruder tries to break in, the switch gets opened, and once the switch gets opened, the reset pin gets disabled, and the timer starts its actual operation, and then it sends signal pulse to the speaker. The speaker receives the signal pulse and starts making noise. So this was the circuit part. Now let's move to the simulation to see how the simulation actually shows results. Thank you. As you can see that the VCC part is connected to the timer to provide necessary power. Then the reset pin it's connected to a switch, and the switch is grounded. Then the output of the timer is connected to a speaker, one end of a speaker. So if we run the simulation, initially it does not do anything because the reset pin, the switch is connected and it controls the reset pin. The reset pin doesn't let the timer send any signal to the output, and the speaker doesn't make any sound. So if now we disconnect the switch, it starts making noise. What actually happens is that the speaker receives an output signal from the timer and it starts making noise. So what the reset pin does is actually the reset pin controls the timer. Doesn't, if it's turned on, it doesn't let the timer send any signal pulse to the speaker. So the speaker doesn't make any sound. Now let's attach a green LED to just to see the signal pulse with that we're getting an output from the signal pulse. So if we connect the green LED, one end to the output and the other end to the speaker, then we can see, if we run the simulation, we can see that the green LED starts blinking once the switch is disconnected. So this proves that we're getting a signal pulse from the timer that is traveling from the output to the speaker, and then the speaker starts making noise. So this was the simulation part, everyone. Thank you.
Hello everyone, my part is discussion, challenges and limitations. The project was completed with the help of 555 timer working in astable mode. During the project work, we got to learn how the astable mode actually works. In this way, we got to implement the 555 timer in real-life project in a knowledgeable and fun way. Challenges and limitations. Components. Finding the accurate rated resistors and capacitors might be challenging while implementing the project. False alarm. Ensuring a low rate of false alarms is essential to prevent unnecessary disruption of users. System reliability. Dependable operation is crucial. The system should withstand environmental factors, power outages, and potential tempering. Ethical use. Responsible deployment of such technology involves transparency and clear communication to users about the system's purpose and capabilities. Disturbing sound of the alarm. They might make uncomfortable sounds while alerting. This might cause unnecessary chaos and permanent hearing damage or loss. This is not the purpose of the project. We need to make sure that the alarm sound frequency is the range of soothing sound. Future directions and innovations. The Intruder alarm system landscape continues to evolve with advancements in sensor technology, artificial intelligence, and connectivity. Machine learning algorithms can enhance the system's ability to differentiate between authorized and unauthorized activities, reducing false alarms. Integration with other smart systems such as surveillance cameras and access control offers comprehensive security solution. That was my part. Thank you.